Welcome to the ENME 351 video lecture series. This is part one of a three-part installment where we'll be taking a look at serial communications, variables, and control structures including loops. This lesson focuses on serial communications. Serial refers to communication between two digital devices where bits are transmitted one after another, typically on a single pin. This is in contrast now to parallel digital communications, where we use lots of pins to send lots of data all at once. Now, when I connect my Arduino to my laptop, I'm making that connection via USB. USB stands for Universal Serial Bus, and this is because I'm making a serial connection here. And this serial stream is a series of ones and zeros that's used to convey information. So it might look something like this. And I'll have a high and a low, such as 5 volts and ground, that I'm switching between. Serial packets contain a number of bits of information, along with control or overhead information as well. So here the stream is normally high at 5 volts. Then we'll send a start bit to indicate the beginning of a serial packet. We'll follow that up with a 0, a 1, a 0, 0, a 1, 1, 1, and a 0. This will give me 8 bits or a byte of information. And then I'll send that signal high again as a stop bit to indicate the end of my serial packet. So in this case then, it's actually taking me 10 bits to send 8 bits of information. And it's important to describe the rate at which these bits or this information is being transmitted. So the serial rate is typically denoted in terms of baud. Baud is defined as bits per second. Really, it's actually symbols per second in the most generic sense, but for everything we're doing here, bits per second is adequate. A typical baud rate is on the order of 9600 bits per second, or BPS as it's abbreviated here. And this tells me it takes about 100 microseconds to transmit 1 bit of information. So if you recall the 10 total bit packet, a start, a stop, and 8 bits of information that we were discussing previously, it would take on the order of 1 millisecond to send that serial packet. Now we can transmit at faster rates. For example, we can go up to 19200 BPS. This is 19,200 bits per second. And it'll take on the order of 50 microseconds to transmit each bit at this serial rate. We could go up to something like 115,200 as well. We're looking at about 9 microseconds per bit. But what you'll find as you get up to these higher serial rates, instabilities will start to creep up. You may end up actually missing packets or missing information. So certainly with your Arduino, you want to try and stick to a more reasonable, more stable rate. Something like 9600 or 19200 should work just fine. Let's take a look now at the Arduino serial library. So let's start by heading back to the Arduino homepage. Click on Learning and then head down to Reference. And if you scroll down to the bottom of the language reference page, you will see a link here to the Arduino serial communication library. Now, the library is a collection of functions that are related in some way. So all of the functions you see here on this screen are related to serial communication with your Arduino. And there's a couple interesting functions right off the bat. Begin will be important at some point. Available, find. You certainly use frequently throughout the semester print and print line to print information to your serial monitor. And there's several other interesting functions such as write and so forth. So let's go ahead and click on Begin and take a look there. You'll see that Begin is setting the data rate for your Arduino, right? So the rate at which you'll be transmitting information. And you see here the rates that are available from 300 bits per second. Here's 9600 bits per second, 19200, and as we discussed, all the way up to 115,200. And also interesting to note here that pins 0 to 1 on your Arduino, if you take a look at your Arduino Uno board, these pins are designated for serial communications. So you'll see on your Arduino that pin 1 is designated for transmission and pin 0 is designated for the receive. So TX and RX are serial communications on your board pins 0 and 1. Here we have the syntax for using serial.begin. So you'll type serial.begin into your Arduino IDE, and then you'll give it a speed, where the speed is one of these baud rates. Let's put this into a sketch by typing serial.begin in our setup function, and we'll assign 9600 baud as the serial rate. And with this sketch, I'd like to print information to the serial monitor. So let's go back to our Arduino serial library, and let's take a look at the available functions here. You'll notice print line, or println for short, and write. And let's go ahead and click on print line. And you'll notice that print line is going to print information or data here to the serial screen, to the serial monitor, that's human readable, right? So it's in a form that you and I can actually read and digest. Whereas the write function, WRITE, will write or print binary data to the screen. Now you also notice the print line function here is printing data that we can read, and it's also entering a new line character after each bit of information. So this is equivalent to hitting the enter button on your laptop. Let's use this print line function then to send information to the screen. Let's go back to our sketch, and we'll type in serial.println, and let's say hello world. And we'll go ahead and upload that to our Arduino. With our sketch uploaded, let's take a look at the serial monitor. And voila, hello world. And if you go ahead and hit the reset button on your Arduino to cycle power and release the button, you'll notice then hello world again. Now this sketch in its current configuration will only print hello world to the screen a single time. So if we wanted to print that over and over and over again, we need to move our serial.println command from setup, which is running a single time, to loop here. And you'll notice that there was nothing in loop previously, right? I don't have to put code in loop, but I will put code in loop function now because I'd like to print hello world over and over and over and over again. So let's go ahead and upload our sketch to our Arduino. And let's take a look at the serial monitor now. And you'll see now we're printing hello world over and over and over and over again at 9600 baud. And take note of the auto scroll box here as well. You'll notice it defaults to auto scrolling. You can go ahead and stop that if you want. It's continuing to scroll in the background, right? But we're seeing now just a snippet of the information. And if I click the auto scroll button again, it'll just continue to scroll forever and ever and ever, or until I cycle power, or lose power for that matter, to my Arduino. Let's also take a look at using the print function as opposed to the print line function. We'll go ahead and erase the ln and re-upload our sketch to our Arduino. And if we take a look at the serial monitor now, we'll see that this line is never ending, right? We've gotten rid of the new line character, and this is just continuing to auto scroll from left to right. Let's go back in and return to the print line function. And in serial.begin, let's change from 9600 up to 19200. Let's transmit at a faster serial rate and re-upload our sketch to our Arduino. When I open the serial monitor now, I'm getting pure gibberish on my serial monitor, and the key here is that my Arduino is transmitting at 19200, but my laptop is actually reading at 9600. So I need to change my laptop to 19200, and I'm back to auto scrolling here, hello world, with a new line character after each hello world. Let's utilize this functionality then to create a basic data acquisition system. You'll see in the code here, I'm still transmitting at 19200 baud, and I've set pins 2 and 4 as inputs. So I'm going to use pins 2 and 4 on my Arduino board. And in my loop function, I'll be doing a digital read of pin 2 to read the state of pin 2, whether it's high or low, as well as a digital read of pin 4. So I'll read in the states of pins 2 and 4 using these digital reads. And I'll use 3 serial.print commands here. So I'll print the state of pin 2, I'll then print a comma, and then I'll actually print line the state of pin 4. That'll give me a new line character, again, similar to hitting the enter key on your laptop. And then I've introduced this delay function here. This will delay the output on the serial monitor by 1 second here. This is 1,000 milliseconds. So I'll have a delay in between each reading and printing to the serial monitor. Let's bring up the serial monitor, and what do we get? Well, we have 0 and 1, right? So pin 2 is currently connected to ground, and pin 4 is currently connected to 5 volts on my Arduino Uno. Now, if I switch the two, let's say I take pin 4, send that to ground, and pin 2 and send that to 5 volts, you'll see I'm now reading 1, 0, right? So I'm actually sensing the state of pin 2 and pin 4, and then using the serial.print commands, print and print line, to send that information to the screen. And then I have a delay such that it's not scrolling by so quickly, and the user can comprehend that information. So here I've gone ahead and switched the pins again, and just demonstrating the ability to sense that information and send that over the serial stream to the monitor.